What's up, guys? It's Mr. Bringle, and today we're going to be going through the notes for motion and forces. This will be completed on page 19 of your notebook. So moving right into it today, we're going to look at how balanced and unbalanced object or forces act on an object, and look at some different types of friction and be able to list some examples for those types of friction. So just a very basic definition of a force is a push or a pull that's applied to an object. So when you push on a lawnmower or pull on a rope, you're applying a force to something. And there's forces all around us, even objects that are sitting on a desk. There are forces being exerted, like a coffee mug that's sitting on a desk is pushing down on the desk, and the desk is pushing back up on the coffee mug. Now, net force is when you have more force acting in one direction than another. So if you have no net force, this first situation here, the forces are equal. Okay, so that means that if somebody was pushing on a box to the left and someone else was pushing on it to the right, the forces that they're pushing with are equal, meaning that the net force is zero. And you see these arrows here. Let me get my, you see these arrows right here that are what we call vectors in physics. So vectors are represented by arrows, and the length of the arrow tells you how much. So in this case, the length of the arrow is telling you how much force. So you notice that the force to the left is equal to the force to the right. And so we would say that the net force here is equal to zero. And so when you have a net force of zero, an object will either not move or it could be moving at a constant velocity. Because when a net force is applied to an object, it causes the object to accelerate. So if you have a larger force in one direction than the other, it will cause the object to accelerate. If they are equal, you could have an object that's already moving and it stays at a constant velocity, or it could be a stationary object that stays still. So looking at this next example here, this is one where the forces are unbalanced. So you can see that the arrow that's pointed to the right is larger than the one that's pointed to the left. So sometimes you might see it like this, a large arrow here and then a small arrow here. So if we said that to the right was the positive direction and to the left was the negative direction, then we would say that the net force here was some positive value. Okay, so the net force was to the right. So in this situation, this box that's being pushed would have a net force pointed to the right and therefore would accelerate to the right. Okay, and lastly here, we have a combination of forces. So when two people push on a box together, their forces are combined and it creates a larger force. So this would be like this. If you have an arrow pointed this way, there's somebody's force, and then another person that's also pushing in that direction, that's going to equal basically adding those two arrows together. So you have a force that has a larger vector, a larger arrow there. Okay. So the point here is that when you have forces that are pointed in the same direction, so let's say that the to the right is positive again, then you're going to add those two arrows together to get the larger arrow, which I'll label as two pluses here. Okay. Now, when you have the arrows that are pointed in opposite directions, they subtract from each other. So that's the big thing here. And I'll go back to my first one and label this. This would be in the positive direction. This would be the negative direction. So that's why the net force is zero on the first example, because when you have a force that's positive and a force that's negative, they subtract from each other. So opposite directions subtract. Whereas if they're going in the same direction, they would add together. Okay. So I'm going to go ahead and erase this here and we'll move on. Friction is the force that opposes sliding motion of two touching surfaces. So you might rub your hands together and they start to feel hot. Well, that's because of the friction in between your two hands. You might think about rolling a ball across a smooth surface and it rolls for a long time. But if you roll the ball across the carpet, it slows down pretty quickly. Well, there's more friction between the ball and the carpet than there is between a ball and the smooth surface. Okay. So friction's caused by microwelds, which are just tiny little bumps that you can't see with your naked eye on objects. And all objects have some sort of friction. In the real world, the thing that might have the least amount of friction would be something like ice. Or you might have played air hockey before, and if you've played air hockey, the puck doesn't move very well until you turn the air on, right? Well, there's a lot of friction between the puck and the table without the air, but when you turn the air on, it lifts the puck up a little bit and makes it so that it reduces the friction, right? It lifts it up so it's not in contact with the surface of the table. Okay, so then it moves really easily and it slides around and goes all over the place very easily. Unless, like my family, your little sister spills Coca-Cola all over the air hockey table and clogs up the air holes. Okay, so there are a number of different types of friction, and we're going to start by talking about static friction. Static means not moving, okay? So stationary, think static, stationary. And this can be a little bit confusing because if an object is sitting still, so let's use the refrigerator as an example. When a refrigerator is sitting still, static friction is not acting on it until you start pushing on it. So when you push on a really heavy object and it doesn't move, like a refrigerator, static friction is holding it in place. Because remember what I said earlier, if a net force is applied to an object, it causes it to accelerate. So static friction isn't actually acting on the refrigerator while it's sitting still. It kicks in once I start to push against it. Because if I'm pushing against it, something's got to be pushing back toward me to keep it in place if it doesn't move. Okay. And if static friction was always acting on the refrigerator in some direction, then it would be moving unless something was opposing it. Now, sliding friction is probably the one that you think of more commonly. The example here is sledding down a hill. So obviously, if you tried to go sledding on grass, not going to work so well. If you try to go sledding on snow, it's going to work a little bit better. So more friction between the sled and the grass than there is between the sled and the snow. But any two objects that are rubbing against each other as something is moving, sliding friction. Now, rolling friction is similar, but it just is something that's rolling like a wheel. So a skateboard that's moving on the ground, right? So again, you might think maybe a skateboard on, say, a gym floor would probably move pretty well. You could probably kick off and roll for a while versus skateboard on some like hard concrete or something, more friction, it'll slow down quicker. The last one is fluid friction. And fluid friction is not, I think when people hear the word fluid, they think liquids, but gases are also considered fluids. So fluid friction can refer to friction in something like water. That's an actual liquid, or it could also be friction in the air, which is a gas, right? So when you go skydiving, and that type of friction specifically is called air resistance, which is what we'll talk about here. So this is simply just friction in air, and it does depend on the size of the object, the shape of the object. So if you think about this person right here that's kind of like spread out like this, there's a lot of surface area, and so the air is being pushed. You can kind of see how the air is being pushed out like this. Well, that's not very streamlined, but imagine if the person reoriented so that they were vertical, right? And it was more like a pencil that was falling through the air. Well, the air is going to go around them a little bit better. So they're going to move faster when they're headed straight down, like head first, than if they spread out because there's more air resistance when you have a larger surface area. So the focus question here, what does the force of friction between two objects in contact depend on? And that's a question that I would like for you to answer yourself, and then we'll answer it in class. And then your friction foldable, you have some instructions here, but you have access to this slideshow. So I'm going to ask that you just go back and look at the slideshow. And then there are a couple videos that have instructions on how to make the foldable and then also how to complete the assignment. So please make sure to check for those videos on Canvas. Let me know if you have any questions.